Welcome to the deep dive. Today, we're going to be tackling a question that's both mind-boggling and pretty fundamental. Is our universe unique or just one of many?
Yeah, it's a question that's really captivated physicists and philosophers for centuries. And today we are going to be diving deep into an academic paper. It's titled Multiverse Cosmological Models, to explore this really fascinating concept of the multiverse.
Okay, so let's unpack this. What exactly is a multiverse?
Well, think of it this way. What we traditionally call the universe, all the stars, the galaxies, the planets we can observe, all that might just be one small part of a much grander reality. And the multiverse suggests that there could be countless other universes out there, each with its own unique set of physical laws and properties.
So instead of just one cosmic recipe, there could be an entire cookbook with universes as different as a souffle is from a stew.
Exactly. And that challenges one of the bedrock principles of cosmology, the principle of mediocrity. This principle suggests that our place in the universe is nothing special, just an average random spot.
But if there are all these other universes with different laws of physics, suddenly our universe with its life-permitting conditions starts to look pretty special, doesn't it?
It does indeed. This is where the concept of the biophilic principle comes in. It essentially says that we can only observe universes that are capable of supporting observers like us. In other words, the very fact that we exist to ask these questions means our universe must have the specific properties that allow for life to arise.
So it's like we're looking through a cosmic keyhole, and the only universes we can see are the ones where that keyhole exists in the first place. Like we're inherently biased by our own existence.
That's a great way to put it. And that bias is at the heart of many debates about the multiverse. Now, our source material delves into several different models of how these multiverses might be structured. One of the earliest ideas comes from Ludwig Boltzmann, who pondered whether even within a universe with uniform laws, random fluctuations could create pockets suitable for life.
So even without different physical laws in different universes, just by chance, some regions might end up with the right conditions for life.
Precisely. Imagine a vast cosmic ocean. Most of it might be too hot or too cold to support life, but randomly you'd get these little islands with just the right temperature. That's what Boltzmann envisioned.
Okay, that makes sense. But the source also mentioned some more complex ideas like string theory and eternal inflation. These sound a bit intense.
They are, but they're also incredibly fascinating. String theory suggests that the fundamental building blocks of reality aren't particles, but tiny vibrating strings of energy. And the way these strings vibrate determines the physical laws of the universe.
Okay, so different vibrations, different laws.
Exactly. Now, string theory predicts a vast landscape of potential vacuum states. Think of them like different stable configurations of these vibrating strings. Each vacuum state would lead to a universe with a different set of physical laws.
So it's like string theory provides the ingredients, and each vacuum state is a different recipe using those ingredients.
A perfect analogy. And that's where eternal inflation comes in. This theory suggests that our universe is just one bubble within a vast, eternally inflating multiverse. Each bubble represents a different vacuum state, a different set of physical laws dictated by how the strings are vibrating in that region.
Whoa. Okay, so instead of islands in an ocean, we now have bubbles in a cosmic foam bath, each bubble a separate universe. My head is starting to spin.
It's a lot to take in, for sure. But we're just getting started. There are even more mind-bending models out there, from the many worlds interpretation of quantum mechanics to the idea of black holes birthing new universes.
Hold on, black holes birthing universes. That sounds like something straight out of science fiction.
It might sound like science fiction, but it's a serious theoretical concept. Lee Smolin proposed that when black holes collapse, they might not just disappear. Instead, they could create new universes, each with slightly different physics. It's a kind of cosmic evolution where universes reproduce through black holes.
Okay, that's wild. So we've got random fluctuations, bubble universes, quantum splits, and black holes as cosmic nurseries. Is there any limit to how strange this can get?
Well, there's also brain theory, which imagines our universe as a three-dimensional brain floating in a higher dimensional space. Imagine a flat sheet of paper that's our universe embedded in a larger multidimensional space. There could be other brains out there, other universes existing parallel to our own.
Okay, I think I need a moment to process all of this. We've gone from cozy little pockets of order to an infinite sea of bubble universes, black holes birthing new realities, and even other dimensions.
And we haven't even touched on the most extreme idea of all, Tegmark's mathematical universe hypothesis.
Okay, hit me with it. How much stranger can it get?
Tegmark suggests that every mathematically consistent structure, every equation, every logical possibility actually exists as a physical universe. It's a truly radical idea.
So not just different physics, but potentially different math in these other universes.
Precisely. It pushes the boundaries of what we even consider possible in terms of reality.
Wow, this is a lot to digest. But before we get lost in the infinite possibilities of the multiverse, let's take a step back and ask, why are these theories even being proposed? What's the evidence, or at least the motivation, behind these mind-bending ideas?
That's a great question, and it leads us to one of the most intriguing arguments for the multiverse. The concept of anthropic fine-tuning.
Anthropic fine-tuning. That sounds like we're adjusting the settings on some cosmic machine. But what exactly are we tuning here? Okay, so we're talking about anthropic fine-tuning. It sounds like we're saying the universe is perfectly set up for life, almost like it was designed that way.
That's the essence of it. Yeah.
Yeah.
The idea is that the fundamental constants and laws of physics, the very fabric of reality, seem remarkably well-suited for life to emerge. It's as if these values were carefully chosen or adjusted to allow for our existence.
But wouldn't that imply an incredible coincidence? How do multiverse proponents address that?
That's where the multiverse comes in. If there are countless universes with different values for these constants, then it becomes statistically likely that at least one of them, our universe, would hit the cosmic jackpot and have the right conditions for life.
So instead of one incredibly lucky universe, we're just one of many possibilities, and we happen to be in the one where the conditions are right for us to exist.
Exactly. It's like buying a lottery ticket. If you buy enough tickets, eventually someone's going to win, even if the odds for any individual ticket are incredibly small.
Okay, I'm starting to see how the multiverse idea could explain this fine-tuning. But what kind of fine-tuning are we talking about? What are some examples?
Our source material dives into some fascinating examples. Take the process of carbon production, for instance. Carbon, as you know, is the backbone of life as we know it.
Right, everything from our DNA to the proteins in our bodies is built on carbon.
Exactly. Now, carbon is formed in the hearts of stars through a process called the triple alpha process. This process relies on a very specific energy resonance. If the strong nuclear force were even slightly different, this resonance wouldn't occur, and carbon would be incredibly rare in the universe.
So if that force were just a tiny bit stronger or weaker, the universe would be a very different place. No carbon, no life as we know it.
Precisely.
Yeah.
And that's just one example. There's also what physicists call the diproton problem. If the strong force were just a tiny bit stronger, protons would bind together too easily, forming diprotons instead of deuterium.
Diprotons, what are those and why do they matter?
A diproton is simply two protons bound together. Now, they're not stable in our universe, but if they were, the early universe would have been dominated by helium, leaving very little hydrogen to form things like water and stars like our sun.
So no water, no stars like the ISA, and that doesn't sound very life-friendly. It's amazing to think that such a tiny change in one force could have such a dramatic impact.
It really is. And the source goes on to highlight other examples. For instance, the weakness of gravity is crucial for a universe that can support life.
If gravity were stronger, wouldn't everything just collapse into black holes?
Not necessarily, but a stronger gravity would mean a smaller, younger universe, with stars burning out much faster. It's hard to imagine complex life evolving in such a rapidly changing environment.
So we need a universe that's big enough and old enough to give life a chance to get going, like finding the sweet spot on a cosmic timeline.
Exactly. And then there's the puzzle of the cosmological constant. This represents a kind of anti-gravity force that pushes everything apart.
I remember reading about that. It's something to do with the energy of empty space, right?
You got it.
Yeah.
Now, based on our understanding of quantum mechanics, this constant should be incredibly large, leading to a universe that expands too quickly for galaxies to form.
So too much anti-gravity. Everything flies apart. No galaxies, no stars, no us.
But here's the thing. The observed value of the cosmological constant is incredibly small, much smaller than theoretical predictions. And while we don't know why this tiny value seems to be just right for a universe that allows for stars, galaxies, and ultimately life.
So it's like someone carefully calibrated this cosmic dial to produce a universe that could support us. It's all starting to feel a bit like a Goldilocks story, isn't it? Not too hot, not too cold, everything just right for life.
That's a great analogy. And that's why the fine-tuning argument is so compelling for many physicists. It suggests that there's something deeper going on, something beyond just random chance.
Okay, but I'm sure not everyone buys into this. It must be pretty controversial to suggest that our universe is fine-tuned for life, especially when you bring the multiverse into the picture.
You're absolutely right. The multiverse hypothesis and the anthropic reasoning that often comes with it has generated a lot of debate in the scientific community. Some physicists find these ideas compelling, while others find them highly speculative and even troubling.
So what are some of the main arguments against the multiverse? What are the skeptics saying? So what are some of the main arguments against the multiverse? What are the skeptics saying?
Well, one of the biggest criticisms is that the multiverse might not be truly scientific. Some argue that since we can't directly observe other universes, their existence can't be tested or falsified.
So it's like saying, there's an invisible dragon in my garage, but you can't see it or hear it or feel it, so you just have to trust me. It's not very convincing, is it?
Yeah, it does raise questions about what constitutes good science. However, multiverse proponents counter that a theory can still be scientific, even if it deals with unobservable entities, as long as it makes testable predictions about our own universe.
So maybe we can't see the dragon directly, but we might be able to see its footprints or the scorch marks from its fire. Is that the idea?
Exactly. For example, some multiverse models predict that collisions between bubble universes could leave observable imprints on the cosmic microwave background radiation. That's something we can actually look for with our telescopes.
Okay, so it's not entirely outside the realm of testability. But even if we could find evidence, some physicists argue that invoking the multiverse is still a bit of a cop-out. It's like saying, we don't know why the constants are so fine-tuned. So let's just say there are infinite universes and call it a day.
That's the anthropic reasoning is lazy argument. Some worry that it discourages the search for deeper, more fundamental explanations within our own universe.
Yeah.
Instead of asking, why is the cosmological constant so small? We just shrug and say, well, it had to be small somewhere.
Yeah. It does feel a bit like giving up on finding a real answer, like saying, I don't need to know how this watch works. It just tells time because that's what watches do.
Right. It could stifle scientific curiosity.
Yeah.
And even if we accept the multiverse, it doesn't really solve the problem of fine-tuning. It just shifts it up a level.
What do you mean?
Well, instead of explaining why our universe is fine-tuned, we now have to explain why the multiverse itself is structured in a way that produces at least one life-permitting universe. It's like saying, we don't know why this watch tells time, but it must be part of a bigger machine that makes watches that tell time. It doesn't really answer the fundamental question of why the time-telling exists in the first place.
So it's turtles all the way down, even with a multiverse. But there's another critique that we touched on earlier that I'd like to explore further, the idea of simulated universes.
Yes, the simulation hypothesis. This one really gets into some mind-bending territory.
It does. Basically, the argument is that if there are advanced civilizations out there capable of creating incredibly realistic simulations, then maybe we're living in one right now and don't even know it.
That's the gist of it.
Right.
And if simulated universes are possible, they might vastly outnumber real universes.
So statistically speaking, it's more likely that we're living in a simulation. That's a pretty wild thought. But here's what I don't get. If our reality is just a simulation, doesn't that make the whole idea of using physics to understand the multiverse kind of pointless? I mean, the simulated laws of physics might have nothing to do with the real laws governing the multiverse.
That's an excellent point. It creates a real conundrum. If we're living in a simulation, how can we know anything about the real universe beyond the simulation? It's almost like trying to escape a video game by studying the code of the game itself.
So we're stuck in the simulated world, potentially unable to access the true nature of reality. I have to admit that's both fascinating and a little unsettling.
It certainly challenges our assumptions about what we can know and how we can know it. But that's what makes this whole discussion so intriguing. It pushes us to think beyond our limited perspective and confront the mysteries that lie at the edge of our understanding.
So where does this leave us? Is the multiverse a legitimate scientific idea or just a philosophical rabbit hole?
Well, I think it's a bit of both. There's no definitive answer yet, and the evidence is still being debated. But even if we never definitively prove or disprove the existence of the multiverse, I think the value lies in the questions it forces us to ask.
I agree. It makes us think about our place in the cosmos, the nature of reality, and the limits of our knowledge. It reminds us that there's always more to learn, more to explore, more to discover. And who knows, maybe someday we'll find that definitive piece of evidence that confirmed or refutes the existence of the multiverse.
Until then, we'll just have to keep searching, keep questioning, and keep our minds open to the infinite possibilities.
Well said. Thank you for guiding us through this incredible deep dive into the multiverse. It's definitely given us all a lot to think about.
It was my pleasure. Always happy to explore the biggest questions out there.
And to all our listeners, thanks for joining us on this journey through the multiverse. We'll see you next time on The Deep Dive.